In today's lessons, we're going to go a little bit deeper in knowledge with finding zeros. In our first lesson, when we were finding zeros, we talked about a zero was the same thing as a x-intercept. Okay, but now our x-intercepts or zeros are not going to all be integers. We are going to have some that are going to be decimals, complex numbers, fractions. We really don't want to write our answer as a decimal, so I'm going to scratch that out. And instead of decimal, I'm going to write fractions. And since we have to have a fraction or we have complex numbers where we have imaginary x-intercepts, we're going to use some information we've already learned this unit to help us get those answers. So we're going to talk about synthetic division again. And then once we've done synthetic division, then to solve it, we're going to go back and talk about factoring and quadratic formula. But before we get to the problems, we got a couple new terminology things that we should talk about. So here we go. Multiplicity. Multiplicity will tell you how many times a zero counts as an answer. Okay, and there are two types of multiplicity. They are even and odd. Even shows up a lot more than the odd multiplicities. So let's talk about even multiplicities first. To have an even multiplicity, you must have a U-shape that starts directly on the x-axis. So if you look at my picture off to the side, you're going to notice I have a U-shape, and the U-shape starts directly on the x-intercept of the number 5. So that means 5 is going to count more than once. And since it's an even multiplicities mean that your answer counts twice. So you would say 5, 5, which means it starts, you have 2 of them. Or you can write it as 5, and I abbreviate multiplicity of 2. Okay, odd multiplicity. Odd multiplicity, the answer is not going to count twice. It's going to count 3 times. And for an odd multiplicity, you're going to have what kind of looks like a sideways S, and you're going to have the flat line of the sideways S right on the x-intercept. So for this one, you could either write down 5 3 times, or you can say 5 multiplicity of 3. All right, to find these, we are going to use technology to graph them and to look for the nice, neat integer zeros. And then if we are missing any zeros, we're going to have to use synthetic division to help us out. So I'm going to switch back over to Desmos, and I'm going to type in the first one. So 2x raised to the 4th minus 8x raised to the 3rd plus 6x to the 2nd plus 8x minus 8. Okay, and so remember, zeros are called x-intercepts. So you're looking for where it crosses the x-axis. So I have a nice point right here at -1, 0. So on A, my first 0 is at -1. Then I have a second 0 over on the right side at +1. So +1. Then if I go back to my picture, I have another 0 at 2, 0. Now, when you look at the one at 2, 0, do you guys notice that you happen to have a little bit of a U shape right here? So I'm trying to outline it. And since you have a U shape and it sets right on the x-axis, that means that answer counts twice. So you can either write 2 twice, or you can write it as 2 multiplicity. Sorry. Of 2. So either way. Now, we're done. And how do we know we're done? Well, in this problem, does everybody notice the highest exponent was 4? The highest exponent in the problem will tell you how many zeros you are supposed to have. So if my highest exponent is 4, I better have 4 zeros listed, and I do. So all of them were nice and neat. Yay, I didn't have to do any work. Unfortunately, that will hardly ever happen. So let's move on to the ones that are going to require us to do some more work. So let's move on to B. So I'm going to go back to Desmos, and I'm going to type this one. So 4x to the 4th plus 28x to the 3rd plus 33x to the 2nd minus 40x minus 25. Now, I don't even have to zoom this picture in because I don't care about anything other than the zeros, and the zeros are x-intercepts. So when I look here, I'm going to notice that I have an x-intercept at -5. That's a nice, neat integer. Then I have a decimal, so we can't count the decimal answer, so I'll come back to that later. And then I have another decimal answer, so I can't count that one. I'll have to come back to it later. And then finally, at the very end, I have another nice, neat integer. So really, I only found 2 nice answers from the calculator that weren't decimals, and that is -5 and +1. Now, even though we can see the decimal answers on Desmos, we have to go through and prove that they are really zeros. Okay, so this is where synthetic division comes into play. It doesn't matter which one of our zeros you start with. I am going to start with 1. And then I'm going to list my coefficients. So 4, 28, 33, -40, and -25. So drop my first term, multiply, and then add, multiply, and then add. Keep that up. So multiply, add, multiply, add. And remember, you should always get a remainder of 0. And then we're going to do synthetic division again with what we have with our other 0. So my other 0 is -5. So let's continue with synthetic division. So bring your 4 down. So multiply and then add, multiply and then add, and then multiply, and you better have a remainder of 0. So the first time I did synthetic division, I went from the highest exponent of x to the 4th down to x to the 3rd. Second time I do synthetic division, I drop it down to x squared. So I'm looking at 4x squared plus 12x plus 5 equals 0. And here, this is where I would either factor or I would do the quadratic formula. I'm pretty partial to quadratic formula, so that's what I'm going to do. So I'll write the quadratic formula down here again. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So opposite of b would be -12 plus or minus the square root, and then we have regular b, which is 12 squared, minus 4 times a, which is 4, times c, which is 5. all over 2 times a. So that would be 2 times 4. Okay, so use a calculator to help you out here. So on my calculator, I would take 12 squared minus 4 times 4 times 5. And I got the number under the square root to be 64. Then on the bottom, 2 times 4 is 8. So let's keep going. What is the square root of 64? And hopefully everybody says square root of 64 is 8. It's a perfect square, so there is no square root left anymore. So let's break our plus or minus apart. So negative 12 plus 8 over 8, and negative 12 minus 8 over 8. So on the first one, that will give me negative 4 over 8, which reduces to negative 1/2. And on the second one, I'm going to get negative 20 over 8. And that's going to reduce to negative 5/2. So I'm going to come back up here to the top, and next to my zeros, I am going to put negative 1/2 and also negative 5 over 2. Now, the beauty of decimals is you can go back here and say, all right, well, I got negative 1/2. So if I come back to my graph, is negative 1/2 one of the x-intercepts? And hopefully everybody says, yes, it is. And then negative 5 over 2. Well, if I take negative 5 over 2 and divide it to a decimal, I get negative 2.5. And if I come back over here, is negative 2.5 one of my zeros? Yes, it is. So basically, we are proving how we get the decimal answers, and we're writing the decimal answers as fractions. And then we also do this process because sometimes you're going to have imaginary solutions, and you won't even be able to see those on the graph. So let's go to the next one. So let's go to C, and let's go type that in. So on C, I have x to the 5th minus 4x to the 3rd plus x squared minus 4. Okay. So on this one, I got negative 2, negative 1, and positive 2 as my zeros. So zeros, I got negative 2, negative 1, positive 2. But we're not finished. We are not finished. Because what's the highest exponent in the problem? The highest exponent is 5. So how many zeros should we have? That is 5. And right now we only get to see 3 on our screen. So that must mean that the other 2 zeros are imaginary because I cannot see them. So this time we're going to go do synthetic division 3 times because I got 3 zeros. So I'm going to start with negative 2 and then list your coefficients. 1. Now there is no x to the 4th, so make sure you plug in 0. Then negative 4, 1. There's no x, so make sure you plug in 0 for x, and then negative 4. So drop your 1, multiply, and then add, multiply, and add, multiply, add, multiply, add. And when you multiply and add the last time, you should get the remainder of 0. Yay. So now I'm going to do my next one, which my next 0 is negative 1. So synthetic division again with -1. Drop my first term, multiply, add, multiply, add, multiply, add, multiply, and you better get a remainder of 0, which we did. And then synthetic division one more time with the number 2. So drop my first term, which is 1, multiply, add, multiply, add, multiply, and you get a remainder of 0. So remember, in the original problem, we started with x to the 5th. First time I did synthetic division, it drops to x to the 4th. Next time drops to x to the 3rd. And the last time drops it to x squared. So I'm looking at x squared minus x plus 1 equals 0 to solve. So quadratic formula again. So that's going to switch to +1 plus or minus -1 squared minus 4 times 1 times 1 all over 2 times 1. Part underneath the square root. You should work that out on your calculator, and I came up with the square root of -3. Now, because there's a negative under the square root, that means you have to put an I on the outside. And square root of 3, it's not a perfect square. It doesn't break down with the factor tree, so we don't have to do anything. So we're finished. And remember, because you have the plus or minus, that means that answer really counts twice. So I'm going to go back up here. And next to my zeros, I'm going to add in 1 plus or minus I square root of 3 all over 2. And that is how I come up with my 5 0 answers. Whoops, sorry, hit the wrong button. Okay, so you should try the last one by yourself. So pause the video, give the last one a whirl, and see what you can come up with. Now, the last one is a little bit tricky. I'll let you get it typed in here. Because when you look at this one, people will tell me, oh, Miss Meyer, I only see 1 0, but let me get it typed in before you tell me that. Oh, whoops. I had a small typo there. Let me fix that. Okay. So most people look at this one and they just say, oh, Miss Meyer, I only see one answer, and that's at -2. But this one actually has an odd multiplicity, because do you see it kind of looks like a sideways S? And then we have this little flat line right here at -2. So that means -2 is going to count 3 times. So you are going to have to do synthetic division 3 times with -2. And I'm so sorry I wrote so big and I'm running out of space, so I'll try to squeeze it in here for you. But hopefully you either have done this one and you're checking, or you're just going to follow along. And if you have any questions about the synthetic division part, make sure you remember to ask me tomorrow. Got a remainder of 0. So now we're going to do synthetic division again. And then I got remainder of 0. So one more time, I'm going to do synthetic division. So the first time I do synthetic division, I'm going to go from x to the 5th down to x to the 4th, down to x to the 3rd, down to x to the 2nd. So I am looking at solving negative x squared minus 4 equals 0. Right, I don't even have to do the quadratic formula on this one because there's no middle x, so I can just work on getting x squared by itself. So move the 4 over, it becomes positive. Divide by negative 1, so I get x squared equals negative 4. Opposite of squaring is take square roots. When you take the square root of both sides, you have to have plus or minus. Square root of 4 is 2, and because there is an I under there, that means it's an imaginary. So my missing 2 zeros are plus or minus 2i.